Alright, so here we have a multiple forces in one dimension problem. Okay? So we've got this crane, it's lifting a 1,000-kilogram beam. Now the lift comes in three parts. At the very beginning, the crane accelerates the beam to get it started moving. Okay? And it goes from rest to 0.5 meters per second in 3 seconds. Then for segment 2, it's just lifting it straight up, okay, at a constant speed. And segment 3, it's going from 0.5 meters per second, which was its speed, down to 0 in 2 seconds. And what I want to know is for each segment, what is the force of the crane? So, typical force problem, we want to sit there and say, okay, what are the forces acting on this beam? Turns out there are two forces. There's the crane and there's gravity. So we have Fg down and Fc upwards. Okay? Now, I'm going to make the assumption that down is negative and up is positive for the rest of this problem. That's what we typically do. Hopefully that won't confuse you. Okay, so now we can calculate what the force of gravity is going to be. And force of gravity is going to be the same in all three segments. So we have Fg is equal to 9.8 times the mass, which is going to be 9,800 newtons. And again, this is downwards, which in this case means it's going to be negative 9,800 newtons. The next step we got to do is we got to say, okay, what other information can we get? Don't know anything about the crane. Crane and gravity don't have to be like equal or the same or anything like that. So we got to go find the net force. And fortunately, we have information about the net force. Remember that net force is equal to mass times acceleration. So, for segment 1, the acceleration is equal to change in velocity over time. 0.5 over 3, which is 0.17 meters per second squared. Which means that the net force is equal to 1,000 times that, or 170. In segment 2, it's even simpler. A is 0, which means that F net is, and for segment 3, we actually are going from 0.5 meters per second down to 0, which means that the acceleration is equal to negative 0.5 over 2, or negative 0.25, which means that F net is equal to negative 250 newtons. Give me some units there. Now, how does knowing F net help us find F crane? Well, we know that F net is the sum of all the forces. So F net is equal to F crane plus Fg, which is equal to, of course, F crane minus 9,800 newtons. And so for each segment, if we plug in F net, we can solve for F crane. So for segment 1, we get 170 equals Fc minus 9,800. Fc equals 9,970. For segment 2, we get 0 equals Fc minus 9,800. So Fc equals 9,800. And for segment 3, we get 250 equals Fc minus 9,800. Fc equals 9,550. Okay? So again, all we've done here is we've sit there and we've said, okay, we've got our F net is equal to all of our forces. We've combined that with the accelerations that we found with kinematics, and then we're able to solve for one of the individual forces on its own.